Let's play. What kind of questions did you come across? Make sure your phones are stashed away off your desks in a location that you're not going to be inspired to try them. Trying to figure. Let's sit back here. Okay. Hey, there's a pen on this desk. Awesome. Okay, questions from last night's homework, my friends. 24. All right, problem number 24. So I have a raised to the 0, b raised to the negative 3, over a to the 5th, b to the negative 2, times, is this the right one, Mikey? All right, now friends, just trust me on this. I'm not going to oversaturate you with a whole bunch of problems, but do me a favor. When you're doing these, try not to do, some of you are much smarter than I ever will be, and that's fine. But some of you struggle a little bit with math, so trust me when I tell you this. Take your time when you're doing these. So let's take a look at this first, a to the 0. What is that going to be? That's just going to be a 1, right? It's not a to the first. It's just a 1 goes in place of it, okay? And then these two items need to move. And the a to the 5th stayed there. Okay? Do you agree so far with what I've done? And then, so the black ones are the ones that we're not moving. And the ones that I'll do in green means it's 1. And if I do it in red, that means it's going to move. So these two are going to switch spots. Okay, is that okay so far? And friends, if you have multiple colors you're using on a test or quiz, it's totally fine. I love it. Okay? Now, does everyone feel comfortable with what we've done? The problem's not done, but do you feel comfortable with how we move things? Did I move them all appropriately? Now, notice I actually put a 1 in there for the a to the 0. Because a lot of times people are like, oh, it's 1. And then you start fathoming it to be a to the 1st. A to the 0 is not a to the 1st. So just be very cautious on that. All right, so there's no reason to really go do too much more work to this problem other than let's take a look at our a values. So how many a values does it appear we have up on top? 9. Good. And how many a values are on bottom? 5. Okay, tug of war. Who wins, top or bottom? Top by how many? 4. Now notice I didn't put it all together. I just kind of realized, oh, okay, like bases, we add them up. Now let's take a look at our b values. How many b's appear to be on top? 2. How many b's appear to be on bottom? 5. How many? 9. Okay, tug of war with the b's. If there's 9 on bottom, 2 on top, who wins, top or bottom? Bottom by how many? 7. Very good. Problem's done. Okay. So I think there's definitely a way that you can do these where you don't have to necessarily combine together. You can just kind of use a little logic to get them. What else did you see on any of those problems that were the evens? Because we did all the odds yesterday, right? Okay. What else did you see that I could help you with? Oh, Adrian. 22, you got it. Yeah. Okay, 22 is a good one to ask about because there's kind of a lot going on here. We have some power to a powers that are taking place. So let's take care of the power to the powers. So I'm going to have c to the 7th times c to the 12th. And then I have this 3. I'm going to bring this 3 out front. What is going to happen with c to the negative 25? What's going to happen with c to the 25? What's your negative 25? Yeah, it moves down. Right now it's sitting in the numerator, so we're forcing it down to a denominator. How much? Oh, yeah, it's 4 times. I messed up here though. What is that? C to the 10th. Yeah, we multiply these, right? 2 times 5 and 3 times 4. So power to power, you multiply the exponents. Remember, exponents are like bunnies. When they're on top of each other, they multiply. All right. So I know part of my answer is going to be a 3. How many C's appear to be on top? 22. And there's 25 on bottom. Tug of war, who wins? By how many? 3. Done. Cool. Any others that I can help you work with those problems? We doing okay? Feeling okay about still? This chapter is still, I feel, a much nicer breath of fresh air. Yes? All right. Oh, I didn't get my copy. Sorry. Let's go to our notes. You have today's too? Sweet. All right. Let's go in our books to page 187. Okay, so this next section deals indeed with exponents, but it also deals with something called scientific notation. So we're doing a lot of cross-curricular. But I want to give you some thoughts of scientific notation and where it's used and why it's used. Yes, it is used in science, but scientific notation was developed to be used prior to calculators when you were dealing with really large numbers or really small decimal amounts. Okay? And when I say small decimals, have you ever heard of the unit of length called an angstrom? If so, does anyone know what an angstrom is? It's 10 to the negative 8 meters. Okay? Well, I'm telling you, I'm sharing you where it comes. So 10 to the negative 8 meters means this. So you know the millimeter mark on your rulers? It's the smallest mark. You know what I'm talking about? Oh, yeah. You're going to break that down into 1,000 equal units. The littlest, tiniest mark on your ruler, 1 millimeter, you're going to break that down into 1,000 equal marks in between 1 millimeter and 2 millimeters. So pretty small, right? Yeah. So an angstrom, by definition, is the average distance from the nucleus of a helium atom to its 1 electron orbiting around. That's an angstrom. Okay? I kid you not. And there's mathematical probabilities that show this to be true. The chemistry model does show that we do have positive and negative electric charges. Though we can't see electrons because they are so small, we know they exist because of the properties that exist with chemicals and all the elements. So an angstrom is 10 to the negative 8 meters, which is 10 to the negative 4 millimeters, which you take the millimeter and you break it into 1,000 equal units in between the smallest 2 units on your ruler, and that's an angstrom. Okay, so that's really small. Yeah. All right, so what we're going to do here, if I were to multiply that by 10, I move the decimal 1 place to the right. If I multiply by 100, and then if I divide by 10, notice where the decimal, so right now the decimal falls here and here. And if I divide by 10, I get to here. If I divide by 100, I get to here. So notice the decimal is moving to the right or to the left by multiplying or dividing by 10 or 100. And we're basing that on that first number. Okay, so that's just something to consider. 10 is a very nice thing to multiply and divide by because it's simple. Okay, the reason why 10 is so simple is we have 10 fingers and 10 toes. We are on a base 10 number system. Okay, kid you not, you all like, are you sure? Yeah, I'm sure. Okay, the computer folks get this a little differently. They're on a base 2 system because they deal with ones and zeros. There's only two things that can happen with a computer. You can turn on a circuit or turn off a circuit. That's it. That's all of your stuff that you're using on your phone. It uses zeros and ones. Okay, so if we have something like this, a number expressed in scientific notation when it is in the form a times 10 raised to the b, where blank is between 1 and 10, where a is between 1 and 10. In scientific notation, there can only be one digit before the decimal. So if I had scientific notation, 6.02 times 10 to the 23rd is correct for scientific notation. Now I'm going to give you the same answer. These are the two exact same answers. This one is incorrect for scientific notation because you want a number, then the decimal, and then 2 to 3 numbers after. Does anyone want to know what 6.02 times 10 to the 23rd is? 6.02 times 10 to the 23rd is how many molecules of mass that you would have within 1 gram of any substance of that's on the periodic table. That's how many molecules of that substance would exist. It's called Avogadro's number. It's a big number. Sorry, I'm going with the chemistry today. I figured a little cross-curricular won't hurt anybody. All right, so let's see what in the world we are even dealing here. All right. So rewrite in decimal form. Okay? So this is a positive 5, which means the decimal moves right 5 spots. Okay? So how many spots have I moved the decimal so far? How many spots have I moved it from 9.24 to times to the 5th to 924? 2, 3, 4, 5. So this 924,000 is the same as saying 9.24 times 10 to the 5th. Okay, so notice you have an exponent there. The base of your exponent is 10. And then we're multiplying, 10 to the 5th times 9.24 to get 924,000. So if I have a negative exponent, negative 6, which means move decimal left 6 spots. Ooh, there's a little dyslexia. 6 spots. Okay, now I'm moving the decimal this way 6 spots. 1, 2, 3, 4, 5, 4, 8, 3. So originally my decimal was here. If I moved it 1, 2, 3, 4, 5, 6. That's 6 spots left. Okay? So again, we're taking them out of scientific notation and we're putting them into standard form. Next, we're going to go standard form. So negative exponent, decimal moves left. Positive exponent, decimal moves right, as long as your base is 10. Okay? Scientific notation shouldn't be given to you in something that's not base 10. All right, can I move on? Ready? Yeehaw. All right, so now we want to write this in scientific notation. So I know I'm going to have 2.81, what I'm doing with. So let's see. 1, 2, 3, 4, 5 times 10. Okay, so if I had a really small decimal, I'm going to have a negative exponent. So 1, 2, 3, 4, 5 times 10 to the negative fifth. And then this one. This is not written the right way. So I'm going to change this to 7.36 times 10. I'm going to move the decimal left. But this is a negative, right? So that negative is going to become to the negative 4. Now, this is how we can justify that we got it right. Let's take this and write it. Let's write this as true. Actually, we're fine. So that means 1, 2, 3, 4, 5, 6 times. So this should be the right thing. Hang on. I don't think I needed this. I'm sorry. I'm going to scratch that out. You're like, but I wrote it down. Okay, deal with it. All right, so let's make sure we have this right. So I'm moving my decimal to the left 5 spots. So let's see. Is this in the right spot? 1, 2, 3, 4, 5. That's where the decimal was, right? So our answer is right. Ooh. All right. What do you think? Let's do some of the odds. I'm on page 189. You with me? Page 189. What was this? I don't think we're doing that. We're not doing that. We're not doing that. We're not doing that. All right. All right. So, my friends, let's talk about the speed of light is 186,000 miles per second. Okay, that means every second light travels 186,000 miles. That's pretty fast. You got a quarterback going to throw a ball that fast? That's awesome. I love it. I love it. All right, so first off, where is my decimal sitting right now when I look at that problem? Yeah, at the very end. It's sitting right here. So I want to make this become 1.86 times 10. And this is a big number, so this should be a positive number. So I'm going to go 1, 2, 3, 4, 5. 1.86 times 10 to the fifth miles per second. Number 3, skip. I don't like number 3. I never like number 3, and I keep bringing it up with my group. I like number 3. Oh, but it's a good problem. Okay, 2 raised to the 64th power is 2 times itself 64 times. No. It's big. It is big. All right. So now we want to write each of these in true decimal form. So, oops, number 5. Number 5, sorry. Number 5 is 1.3 times 10 to the negative 2. So this means I need to move the decimal left. Okay? So I have 1, 2, done. So if I move this left, I make sure I put a 0 in. So 1.3 times 10 to the negative 2 is 0.013. Feel all right? So there's a couple on that page to try. Let's go to page 190. You still with me? Waiting. I'm sorry. Good? Everyone else good? No? All right, let's go to number 7. X squared y raised to the third. Ooh. How many of these am I talking about? How many of those am I talking about? 3. So, like bases, add up the exponents. So 2 plus 2 plus 2. So I get x to the 6th. Y is to the 1st. 1, 2, 3. Y to the 3rd. Done. Yeah, he made some good money. If Russell Wilson's his new house? Yeah, baby. Yeah, sweet. All right. So let's multiply these together. What do I get if I multiply those together? -6. If we have a negative exponent, what do we want to do with it? If we have a negative exponent, what do we want to do? Yeah, it's going to move down. There's problem number 9. Okay? So there's 2 parts to it. You have a negative exponent. It's up to you if you move the negative exponent in the beginning or at the end. Still going to get you the same. All right, number 11. 3/8 raised to the 2nd. Well, how many 3/8 am I dealing with? 2. 3/8 times 3/8. 3 times 3 is 9. 8 times 8 is 64. Done. Number 13. X to the 4th over y to the 2nd. So there's no tug of war on this one. Agreed? So power to power. That goes in. That goes in. 5 times 4 is 20. 5 times 2 is 10. Again, it's still not tug of war because our bases are x's and y's. All right, we're doing pretty good. This accounts for me not doing the odd answer videos on Schoology, okay? That means you can watch this video. All right, can I move on? I got to number 13. All right, number 15. Here we go. Number 15. X to the -1, y to the 5th. It's all raised to the 3rd. Okay, so we can get rid of the negative exponent first, or we can deal with it last. I'll deal with it last. So that goes there. That gives me x to the -3 because power to power we multiply. And that becomes y to the 15th. What should I do with the negative exponent? Does the entire fraction flip over, or does the x move down only? Good. So that moves down. Hey, friends, what do I put for a placeholder if everything moves out of a location? Put a 1. There we go. Done. And then problem number 17. Uh-oh. All right. Numerous ways we could start this problem. I think I'm going to move this. So I'm going to do this first. Do you feel comfortable with what I just did? Again, I'm taking my time on it. Now, my critical thinking friends, talk to me about what I did here and why did I do it. Yeah, so I flipped the whole fraction over. Notice the -3 is now a +3. Do you agree? So that's a big step. If you can recognize I have a quantity raised to a negative exponent, then you just flip over the entire quantity and it becomes to a positive exponent. Okay? And there's things that we could do before we bring in that 3. So tug of war with the x's. Who wins, top or bottom? Top by how many? 3. I can't tug of war with the y's because they're both on bottom. So how many y's are on bottom? 7. And I still have the 3 out there. So now that 3 becomes a power to a power. So this will multiply here, and this will multiply here. So I get x to the 9th over y to the 21st. All right. Let's see who paid attention yesterday. What is the answer to number 19?
1.
1. Good. That is an ugly looking problem, agreed? It's an ugly big old quantity, meaning it's in parentheses, and it's completely raised to the first power, or 0 power, so the answer is 1 to number 19. And I would bet you would see one of those on the quiz. So, my friends, I would like for you to finish page 189 and page 190. And I just did the odds. And if you didn't copy them down, well, this video will be saved for later. How's that? Everyone happy?